Alrighty, so where we last left off, we were doing some JavaScript variables. And what we said was that we needed to go a little bit deeper on a couple of topics. We need to go a little bit deeper on, here we go, the what kinds of things variables can be. And then the other one is this keyword part here, which we will define a little bit later. I think actually let's start with a keyword. Probably cover both of those today. So the whole keyword is actually pretty easy to grasp. It's not very complicated, at least as far as I want you to go for right now. The two big ones that you're going to be using all the time are let and const. Those are the two that you're going to use. You can use var. I recommend against it. We're not even going to talk about why until a little while. If you want, we can go down that rabbit hole maybe during class, but it's not really necessary for one of these videos. Just know that var is a little bit outdated, and you should pretty much always be using let or const. Let's talk about exactly why. So let's say I have a variable and I don't want it to change. I know it's always going to be the same. A really good example might be my social security number. So let's say I have my social security number here. Social security equals obviously 1, 2, 3. And this should probably be a string, right? We'll talk about the data types in a second. I'm going to make mine a string. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Great. There's my social security number. And that's never going to change. I always have the same exact social security number. So to expect that to change would be insane. Now I have this as a let, but I probably should put it as a const. Let's see the difference here. So right now it's a let. And what I am going to do is I'm just going to console.log it. We are going to log social security. And of course, when we run this, bam, I get it to print out, and that's totally fine. Now let's go ahead and change it. Now remember, I should not be allowed to change my social security number. That should always stay constant. But I already declared it up here. So now that it's declared, I don't need to use a declarative keyword anymore, right? It's a variable that exists, so I don't need a let or a const or anything like that. And let's set this equal to 7, 8, 9, 10, 11, 12, whatever. That's obviously not a good social security number, but hey, let's run this. And I want you to take a second to guess what might happen. All right. Well, if you guessed that it will print this second number, you would be correct. Bam. And the reason why is because we used this let keyword. Let keyword lets us change it after we define it. However, if we instead choose to use the const keyword, you're going to see something very different. Take a couple seconds to try it out. Tell me what you see. If you get scared, just don't even worry. You'll be good. I need to ignore that. Cool. Go away, phone. I literally threw my phone. All right. So now what I want you to focus on is, let's go ahead and see what happens here. I'm going to run this again, and you're going to notice, boop, uh-oh, I got an error. Why did I get an error? Well, let's see. This says it's a type error because I reassigned a constant variable. And this is really what const means here. Const means you can't change it after you define it. Now, you might ask yourself, why would I want to do that? That's less flexible. And the reason why is there's a couple reasons. First of all, I think technically it runs faster to define a const than a let. Let's not worry too much about that part. The other part to focus on here is that if you think about it, let's say I create an app, and in that app, I have a social security number, right? And then a programmer writes some bad code that alters people's social security numbers, and they do it completely on accident. Well, that means you fucked up, right? So in other words, sometimes we want to program things to where we would rather throw an error in our code than and catch it that way than do something bad with our code. So in this case, it's much better to define a const because we don't want to change the social security number. You should not be allowed to. Therefore, this should be a const and not a let. Now, a general rule of thumb with const and let is that if you plan on changing it, you need to use let. If you don't know whether you plan on changing it, keep it as a const. Look for this error message. And if you get this error message and you know you need to change it to a let at that point. And then as time goes on, you're going to develop a much better intuition for whether or not this thing should be a const or a let. But you should always, I would say a good way to start out is do const as much as possible, except for when you need to not use const. We'll go through some examples where you definitely need to use let instead of const. But for now, that is the difference between let and const. Now, on top of this, we have to talk about data types. So I want you to take a minute to Google what a data type is and maybe look up JavaScript data types. Do that. I'm going to go pee. I'll be back in a minute. And we're back. Now, you don't need to necessarily understand everything that there is to know about data types at this point, but hopefully you have a little bit of an idea of what it is. So a data type is literally, think of all the things that we store in general, right? Let's think about a website for a second. On this website, I have a bunch of different types of data. I have something that stores these texts. I have something that stores the current time. I have an array of data that represents all of these things. I have a few important ones that are simple that we need to go over. So let's go over some simple data types. And first, let's take some notes. So let's do let versus const. And let's go ahead and make those. Let's take these notes. We're going to say, when you define a variable with let, you can change it after defining it. And when you define a variable with const, you cannot change it after defining it. Cool. Now we need to talk about some data types. So these are actually pretty easy, I think, to internally figure out. So let's see. First, we have a string. Can you guess what a string is? Let's see. Well, a string basically represents text. That's really the main thing you got to know about them. It represents some collection of text characters. So we can define it with blank or blank or blank, right? And we're going to call this a simple data type. And what this actually means is we would actually really call this a primitive data type. Let's call it a primitive data type. We're going to give it the good name. Don't worry too much about it. We'll start actually up here. We'll do primitive data types. And for now, this is going to be a buzzword. We're not going to go too deep into it, but it will be something that's helpful later. So cool. That would be a string. Let's go ahead and make some strings. So I'm going to say const string1 equals hello world. Const string2 equals also hello world. And const string3 equals also hello world. All of these formats are valid. Now you'll notice when I save this, because I have a formatter on this, it's actually going to change all these two to double quotes. So that it just changed from single quotes to double quotes. Single quotes still works. It's just the way I have my VS Code configured. It automatically changes it to double quotes. If yours does not do that, please do not stress about that. It does not matter even a little bit. The only reason why you can even define something with both single quotes and double quotes would be, let's say I make a phrase, and this phrase is, that don't matter, my guy. Well, let's see what happens if I change these to single quotes. Notice how it looks all weird? Well, the reason why is that this right here, from here to here, technically is a string, and then it doesn't know what all of this is. So likewise, if you maybe were doing a phrase with like double quotes or something like that, let's try that out. Like, he said to the cashier, yo, where the fuck is my money? Right? And you're going to see this looks strange because, well, I have quotes inside of quotes and it doesn't know what to do with that. So I could change this. Let's see, to that. And hey, look, now it works. And in general, there is ways to escape these quotes, and there's fancy ways of coding, fixing that. But for now, what you can do is, if your shit's not working, like maybe you have quotes inside of your sentence or something like that, you can just use a different type of way of defining a string. So my recommendation to you would be to not go too deep down the rabbit hole on how to like escape strings and all of that shit. I think that if you are just able to understand what a string is, why we use it, for now you're in a good place. Cool. So that's what a string is. And let's go ahead and console.log all of these. We can console.log string1, string2, string3, and we can also console log that phrase. And if we console.log all of these, bam, it says hello world, also hello world, also hello world. He said to the cashier, yo, where the fuck's my money? Except for it says moan. Where's my moan? We need not to say money. Cashier got the money. Cool. So now we know what a string does. Now let's talk about some other primitive data types. We also have numbers. Numbers in JavaScript, there's only one type of number, so it's actually pretty easy. So it's always a floating point number. So 1 is a valid number, 2 is a valid number, 33.33 is a valid number. That's all valid. And JavaScript is pretty intuitive on how it handles math. Other languages are going to be a little weirder with math. JavaScript is actually pretty easy. For example, let's console.log 5. Notice how I don't need quotes around it because a number is intuitively understood by the JavaScript engine. So let's go ahead and run node app.js. Bam, cool. It console logs back out 5. Now let's see what happens if I wrap 5 in quotes. What data type do you think this is? I'm going to give you 10 seconds to figure that out. Yeah, so, all right. So since we wrapped the 5 in quotes, even though 5 is a number, since we wrapped it in quotes, now it's a string of that says 5 rather than actually representing the number 5. So let's go ahead and display that. And hey, do you notice how this pops up in a little bit different of a color than this? That's the reason why it's kind of showing us, hey, look, even though it says the same thing, technically, it's not really the exact same thing. And let me prove it to you. We're going to do 5 plus 5 in here. So I'm going to do 5 plus 5, which, by the way, yes, your code can act just like a perfect little calculator. So I'm going to go ahead and do 5 plus 5. And of course, we get 10. But what happens if I instead do the string of 5 plus the string of 5? Now, does anybody have any guesses? Give it a few seconds for you to try it out yourself. Well, what we get here is shiggity shwam 55. Shiggity shwam 55. Yes, we get 55 because there is different ways of adding things. If you add two numbers, it says, I've added these numbers together. Let me do math on them. However, when you add strings, it does not mean the same thing. If I add a string that says hello world, check it out. Now it goes ahead and it displays hello world. And the general concept here is that all of these operators, add, divide, blah, 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 they don't work the same on strings as they do on numbers. And inherently, this is what a data type is. A data type, it's telling the computer, okay, I get that this is a thing, but what type of thing is it? Because I need to know how to operate on it when you give me these commands. So a string is not going to behave the same way as a number. A number will not behave the same way as a Boolean, which, by the way, brings us to our next value, which is a Boolean. So cool. Here we have some strings. Here we could get some numbers. So let's see. Some numbers would be, I don't know, let's do const 1 equals 1, const 2 equals 4/2. Cool. Great. We have numbers. Awesome. We have now Boolean. Now, Boolean is easy as fuck. Why? Because there's only two values that it could possibly be. So here we have a Boolean. All right. So a Boolean would be const. Is John cool? That's going to be the name of the variable. And of course, the answer will be false. So now notice how this false does not have any strings around it. That's because JavaScript inherently already knows what false is. And that also means you can't make a variable and call that variable false or true for that fact, right? So now let's see what happens when I console.log is John cool? Well, of course, what I do get is false. Now, these are kind of cool. So for example, maybe I'll show you an example of a comparator, which we're not actually going to do right now. We'll do it a little later, but just to show you where these Booleans are useful is if we compare two things, it usually equals a Boolean. Watch this. So if I say const is number even, and then maybe we'll plug in 3. Actually, let's not do is number big is what we'll call it. Number big, and maybe we'll say that the number is 3, and we'll say is 3 greater than 2. That's it. This is a Boolean right here. So let's go ahead and check to see if is number big. Cool. Now, what do you expect to see when I print this? Well, is 3 greater than 2? I say yes. Since 3 is greater than 2, this whole expression equals a Boolean value of true. Cool beans. We're getting some cool stuff in here. Alrighty, so these are pretty much the only simple data types that you're gonna have to work with for a little while, which is nice. Not too complicated, pretty easy. But what about those complicated data types? Cool, so a number, cool, and then we'll have a Boolean. So maybe let's take some notes here. A number can come from an expression. For example, oh, well, let's do some examples. We'll say 5, 3, 2, 1, cool, whatever. It can also come from an expression. So it could be something like 8/2. That's a valid one. Booleans are always true or false. And this can also come from an expression. So for example, if I plug in 5/2 is less than 7, right? Then that would equal true. If I did 5/2 is greater than 7, that would be false. So we could define these things not so explicitly, but as an expression. So in other words, we have the computer calculate what the value of this variable is for me. All right, so now we're going to deal with a little bit more complex of data types. And they are going to be called, if this is primitive data types, you might say to yourself, wow, maybe it's advanced data types. Maybe it's fantastic data types. Maybe it's well-evolved data types. Maybe it's non-Neanderthal data types, but you would be wrong. The technical word that we're going to use is non-primitive data types. Yeah, pretty easy to remember. All right, so now again, you don't have to really know the difference between primitive and non-primitive data types right now. I want to leave this here like this, so that way, as you get better, if you go back in the future, you'll be like, I see what he was doing there. But if you're trying to stress a ton about that, don't worry about it. I'm not going to test you on any of it. The main thing is that you kind of understand how to work with all these. All right, so the first one that we are going to talk about is an array, okay? So an array is kind of a pretty cool thing, and fortunately, I'm not gonna do that in this video because you already just learned a shit ton. Go take a fucking break, get some water, smoke a blunt. I don't give a fuck what you do. Just take a mental cool down. Don't smoke a blunt because you're probably not gonna be able to focus. It's not the best idea. But I'm just saying, go take a break, come back. We'll talk about arrays in the next lesson. Merry Christmas.